So this would be real pretty, but I'll pull the wire off.
That was always recommended as the safest bet, because then you don't have, you kind of know it's not your, you don't set a hard setting and then it's trying to make that and it's too much. Get over the back on.
Let me turn it off. So
No, it's we're on. It's
right,
broadcasting
if
now.
we rewire it, we're going to need to cool it down, aren't we?
We're going to rewire it.
To run, if you want to hit 900 degrees.
Okay.
I don't think it'll reach it otherwise.
Okay.
Let's see, is there another option? I could buy, well, I'm going to have to turn it off to change anything.
Okay. That's fine. We're just broadcasting right now.
Yeah. Well, it won't take very long. Actually, the easiest way, Ryan,
Full plug.
there's an easier way to do it.
What's that?
If you just give me a stripper and a ring terminal.
There you go.
This will take 5 minutes.
In that case, I'll set up a camera so you can talk about it.
Yes, but the piece there is yours. Okay, and I need wire cutter. No, it's got to be diagonal cutters.
On the table, big white table back there.
This one?
Yeah.
Those will work. And double check it's unplugged. What I'm going to do is bypass the temperature controller and the solid state relay and go directly to the AC line coming in, and then we can just plug it into the Variac wires. Then we have a harness that had an AC socket on the end.
I'll go get it.
CPU booted up, Ryan.
Yeah.
That's there for now.
So you plan to wire it up with what?
I'm wiring the heating coil directly to the incoming AC wire. And as long as we power it from the Variac, then we can use the Variac to control the voltage. And we can run it as hot as we ran the other Cantel wire.
Cool.
So it should be able to get to 1,000 degrees at the hot end.
Here's that. And here we go to plug it into as soon as you're ready.
Oh, not that one. This one.
Yeah.
All right. Pull this back up.
Is the variac down in power?
Rack is down all the way.
All right.
And the variac needs to be plugged in.
And it's this cord here, huh?
Correct.
Okay.
Oh, we gotta see the temperatures.
Yeah, as soon as we give it some voltage, they'll
Oh,
turn
okay.
on at about 20 volts.
Okay.
There we
Yeah.
go.
Excellent. Wow, they've got a wide operating range then.
Yeah. Okay, we're coming up on the half hour. There.
Okay, for those people that have just joined us, Alan and Ryan have just hooked up the color calibrator to the variac in order that we can take it as high as possible.
I know you drive it down.
Yeah.
And we're going to test the emissivity of the cast alumina, the fully sintered supplied aluminum tube, and the black high emissivity paint. It's not welded?
No, it's not welded at all.
It's squished.
Yeah, we switched it.
That's odd.
That's a make
It's odd.
Voltage goes down as I turn the variac up because we don't have a reference. So we need to get
Yeah,
this,
don't count any bandwidth right now.
onto there.
Unplug that. Stick it in the banana plug there.
Yeah, but I need to pull some more wire on it.
What's happening to your right hand side?
It's on the low side of the power cord.
It just needs a little more supply voltage.
Last time I did it,
Yeah, the rightmost controller is a different brand and it wants 30 volts minimum on its input.
Okay, so you had it at 70 volts before, right?
Yeah,
In a partial duty cycle.
right. Now I'm running continuous and 210 watts, about 30 volts. So we'll just bring it up in steps and see how it behaves.
Yeah, you've got the temperature. No, you don't have temperature control in there at all.
No.
That's right.
Yeah, I had heard there was another some interesting news about these little pops of aluminum that had no surface oxidations. Then they would drop them into water. I think they were sort of porous, and of course all the aluminum would oxidize. Oh yeah, it was just suddenly hydrogen.
wow.
I wonder how they trigger this.
Maybe they had to keep it.
There's 300 watts.
It's really cool.
I don't remember, but yeah, it was pretty.
No blow yet.
But yeah, I came here.
I'll run slowly.
Telling you, not that it's particularly interesting, but I need to walk around.
Okay.
The UARTs on that series of chips that are in the BeagleBone do not natively support flow control on RS-485.
They learn themselves.
Well, but I mean the chip itself doesn't have any hardware for the timing. So none of the UARTs. I called Scott last night. He explained to me that Hubnet assumes that the RS-485 adapter, whatever it is, does the timing itself. So
We're talking about timing
in RS-485. So the timing from when it switches to receive to transmit.
Yeah.
Because it basically has to send switch to transmit, send a message, and then as quickly as possible switch to receive.
Yeah.
So
Does the controls signals itself?
Yeah.
Or for itself?
Yeah.
So basically, when you send transfer,
that's my understanding.
Here's 500 watts.
Are we getting close to 70 volts?
Nope.
50 volts.
Okay.
But it's 100% duty cycle.
Yeah.
And so at 70 volts, it's going to be cooking.
Yeah. So what that means is that it has to be done in parallel.
And what
That
we ran
problems.
last night with the core heater, we were up around over 90 volts, I think, 1200 watts. And that coil is a little bit higher resistance.
The other issue is I
Okay.
haven't been able to.
So I expect around 85 volts to be the limit for this thing. Remember, power goes up as the square of the voltage.
That's
So,
too bad we
for
don't have a
some reason,
video right
that
now when the temperature controller
RS-485
cut off.
is not open its own
Steady.
control. You have to give it a signal.
It'll stabilize at a certain input power,
Yeah,
but we want to get up to where the Williamson can start to see it.
yeah. And then we want to,
We want to let it stabilize at that.
And then take the cylinders, the black spot, and then the constable.
yeah.
But
Compare it.
at the higher temperatures, the settling
That's
time will
just
be
the personal
faster.
plan. But
You know, it's
fact of the
more
matter is I
radiation.
haven't been able to get it working. I don't particularly well understand how it works in the phone. So my includes ordering one of those super cheap little USB.
So there is a data point. It's settled right around 700 at 50 watts.
I've spent a lot of time on this now.
500 watts, excuse me.
I do like that.
So we'll go to 600 watts.
Okay. But we can't measure the emissivity yet.
But yeah, I
No, we'll get there.
But you can see,
so for
On
instance,
one graph,
on your
or on one
old HUD
picture, what the webcam sees.
there's
at
an
those
RS-485
temperatures.
transceiver.
Mhm.
Is the PCE online now? Because I'm getting data from it on power input.
I'm putting it right up in the same frame.
Beautiful.
That's what I'm right on right now.
So that would mean that the signal control isn't affected by the board being bogged down. And it's taking data or doing something else. So I worry about that happening on the new ones because that sort of system isn't in place. That's presuming we can get it to work in the first place.
Let's see what one of those screen grabs look like. So you have a little webcam here if you want to talk through. It's only 5 frames a second to try and keep the bandwidth down. But the audio should be fine.
USB is serial. It's just a full duplex.
We need to get to 900 for the pyrometer to turn on. Is that correct?
Yeah.
And yeah, it has to be changed.
875.
Okay. So right now we're at 600 watts, and I reckon the limit to be 800, and that should just barely get us up to the temperature we need.
So
We don't have a thermocouple inside, so we can only guess at how hot the wire is. And we found last night it could get really hot before it fails.
When the temperature controller is operating at this temperature, it would cut out when it is satisfied. And when it did, the glow would die,
Yes,
but the temperature would stay the same.
yes,
But as far as flow control,
So we're seeing a lot of light through.
right. And I can simulate that with this magic switch here. Oh, never mind. I'd have to go over there and hit the other switch that I don't have anymore. So,
Well, we rewired it, and
yeah.
you'll have to take our word for it.
So
So it can go hotter.
Well, afterwards you can-
You don't have flow control. Your flow
Well,
control.
we have it on a video the other day.
Oh, okay, that's good.
Let's see what this does.
Ah,
Or your data going back and forth crashes.
okay, yes.
Big change?
Well, it's a big change until it adjusts for the light levels.
Yeah.
Because it's an overall dim
All right.
as well.
I don't know. I just worry
So when you throw it straight in front, that's more like we see. And then when it adjusts there, that's like we see. I'm going to try and screen grab that. Go and throw it in front. Okay. So if you can imagine the rest of the frame isn't green, what we're seeing is what it just sees
In
when
that case, you know,
you throw that IR filter lens in front.
Mike's also gonna order one of the Raspberry Pi 2s, and this is a really neat solution since they can run in Bluetooth now. I like the idea that it costs $40 a total.
Yeah.
Whoever commented on the Facebook list about the dangers of IR exposure, I want to thank you personally. It led me to buy these 3M infrared filters that are meant for glass workers to protect their vision. And this is going to get bright enough that I'm going to flip it down. And they look cool too.
I wonder if they fit into safety glasses. Sure do. How do we do that?
They just slide over the top.
Yeah. Do that.
All right, so here comes 700 watts.
Make sure you're not thinking they're USB gap isolators. Because they just bought a few of those for testing battery social.
Oh, it's much more comfortable.
And I'll bet that those are $90, which costs less than buying a phone that's 45 adapter.
So if we made a music video of this, we call ourselves the Infrared Brothers, the Blues Brothers.
I'm just going to zoom out right now because I just love Alan's T-shirt he's got on here. There we go. I'm going to cut to that camera.
Yeah.
Directly.
So
And we're going to zoom out on that camera. So there you go. He's got his heavy metal T-shirt on.
All right. Leonard rules, bro.
yeah.
We're up near 800 at 700 watts input. Have we got a spot for the Williamson? You're going to hold that, right?
Yes.
You don't want to set a little tripod up on top?
No, because we're going to have to do at each temperature point. We're going to have to do each spot.
Right.
So.
But in some of the applications we're talking about,
What do you think? Is it going to make 800? Sure. Look, there it is.
Way
and beyond. To 800 and beyond. Next step.
Good morning. Nobody knows it's just right here. So, well, you can call the clerk and find out our service. Nobody else. So,
Okay, 800 watts.
Joe is probably good. Now's a good time.
They're making the same. My insight is
So, yeah.
okay. Simon and I are
Yeah.
you know, I feel motivated to at least be out of that as a whole.
Yeah.
But yeah, we're still pretty.
Did I leave a Wi-Fi dongle out here? The day when I read it, you
And
know,
I
it was
never
black.
thought of that.
About
Wi-Fi
that
is
long.
like a really high.
Did I leave a Wi-Fi dongle around here? I didn't have a long antenna on it.
Really?
City Tech City on it.
It's next to the laptop over there.
Perfect. Thank you.
So anyway, then all we have to worry about is.
There's the difference. That's with your lens in front before it color adjusts,
Yeah.
which is much closer to what you see. That's without it.
Yeah.
Yeah, those are great comparisons.
Yeah, if you can't see the images on the
Yeah, that could be neat.
stream of the power input, you can see it on the screen captures.
If we
Where is
if we
that
think of
folder
it in
at?
terms of at what point
That
does
folder
it
has been published on eCut World
more
and
expensive
our
than the alternative.
Facebook page. So it's the same folder that we've used for the glowiness tests. It's the last of the glowiness tests whilst we wait for the
See the air moving up.
purging of the glove box so that we can fuel up a few cores.
Stick them in the silk carb element.
Yeah, and
That's one of them.
well, we're going to do the park off leak test first, haven't we?
Yeah.
Okay, we're at 870 now.
Oh, we're very close to seeing something interesting, so I think I'm going to get up there and get in the way. 873, so let's go and see. Do you want to grab some data here, Ryan? We'll make another spreadsheet up.
Yeah, good. You had a notebook.
So anyway, but I don't even know that we would continue to use that cake for the $5 that we should work.
This is
So if we think about it
that
as
sheet
what
in there
is
if you
more
want.
expensive than $60.
Yeah, that's $5 one word. Something we don't know, but on either one of them, it'd be nice to have the fancy.
Yeah.
Yeah.
Um,
We can have our own, or we can.
Right.
Spend $1.
Well, that's why I was sort of thinking about, if we compare that to the price of the alternative, which
It's going into the same directory which is shared
would be cost
with
effective.
the image scraps.
Because you're RS-45 at that rate, leaving or
Okay.
that's still $40 in total. So you still got a lot of room to play with there.
Yeah. Also, if we put the.
Okay, we got the spotter on this, have we? No. So what we do actually to turn the spotter on, you might be able to see this in camera. Is I'm going to go like that, and then we see a spot there. And we need to have the distance between the end of the pyrometer and the surface we're measuring the temperature about 6 inches. So that's what we're going to do. And the hot zone is up there, so in theory,
And in most cases,
get into a spot there. Where is it? Where is it? Where is it? Where is it? Spot there.
Spot.
Okay, are we seeing anything?
Yes.
978.
978. And what is the emissivity?
What are we on?
We are on the high emissivity paint.
0.79, 0.75 average, it looks like.
Really? Interesting.
Yeah, and they have transfer absorbers in them.
Brian,
Did you hear it? But
No.
most of them. Yeah.
Okay, so that's I'm on it now.
All right, you're on the high
Black spot.
emissivity, the black spot.
But, you know, if you think about it, they.
The thermocouple says 906.
Yeah.
The black spot says, on the Williamson says 979.
Yeah, and the emissivity is 0.73. Looks like.
Okay, can you capture that? You're going to capture it there.
Yeah,
There's not enough
0.73.
bandwidth, it hasn't opened up
Oh,
the
okay.
sheet yet.
And now go right on the thermocouple if you can.
Yeah,
And try.
I'm not giving up on the serial cake, but Scott doesn't really have time to.
There, I'm on the thermocouple now.
For more,
Mm-hmm.
and
Says 1180.
I don't know, thinking about how
1180 roughly, and the emissivity of 0.01.
0.01. I think that's looking through, isn't it?
It's looking right through at the coil. Yes,
So let's see what happens when we actually put it on the
alumina
alumina.
castable.
Yeah, not the alumina castable, the alumina thing. There we go. What's that saying?
That's
0.24, 1225.
So that is pointing at the cast alumina tube.
and the other one's a cast aluminum spot.
You were going to do that next. Yeah.
What was the emissivity? Did you capture that?
No, I haven't got any of these written down.
Okay, should we start again?
Just,
Yeah.
no, I've got the black one.
Okay, so I'll go back on the black one.
I've got the we need the alumina.
Okay, I'm on the black one now.
Yeah. 7.3 and 9,000 degrees.
980 degrees.
980, yes.
And you were saying 0.73.
Yeah.
Black spot, 980.
Yep. Now go to the,
Let him catch that.
yeah.
Okay, I got that. Got it.
Okay, now we'll do the cast alumina.
Wait a minute. I want to add the actual thermocouple and then the thermal.
Thermocouple is reading 920.
920, and then when you put the Williamson on it,
The Williamson, well, I don't know what I'm reading there because it's mostly because of the angle. I'm only reading the tube, what's inside the tube type thing.
that's okay. If you shine it as close as you can to the actual thermocouple.
Yeah, I'm on the thermocouple lump of ceramic.
Okay.
Mm. God, it's not easy.
It's varying from 950 to
I'm not
1,000.
on it yet. I'm on it now.
Low.
I'm on it now.
1140 and then low. It's not stable.
It's just very hard to do that.
You want gloves?
No, that's not it. It's over 6 inches with
Oh,
3 mil
yeah.
spot.
Yeah, yeah.
I'm going to go on the castable now.
Okay, so we have no data point on what the Williamson thinks the thermocouple says.
I will try that again in a
So
second.
is there a alumina tube next to it that you can get?
Yes, I can. Next.
Okay, cast alumina spot.
Okay, castable alumina spot. He's saying
0.2, 1068.
wow. That's really different.
Yeah.
Can I just try that again? I mean, the correct vocal range.
1087
Yeah.
and 0.2. You know.
And 90. Yeah, that was saying 1090 and 0.2. Okay, the
There's an error on this. I don't know what that means.
bare alumina tube
Bare alumina tube.
at about at an adjacent spot there to the black stuff.
Adjacent spot to the black stuff. When we get in focus. Yeah. Okay. Now.
0.41, 1158.
This one's gone error on us.
Or thermocouple popped out.
Probably. Okay. Right. And we're going to try the thermocouple. So it won't be on there long, guys. So.
Yeah.
Right. Ready? On the thermocouple now.
That's low compared to the other ones, which are like
1090 and 0.12.
One that defaults to 150.
right. So chef will handle.
Okay. I'll crank it up a bit.
What a range.
It's amazing, isn't it?
If you try to go faster than 500.
Yeah, I'm going to reset the displays and see if that comes back up.
Some sort of inherent adaptability.
No, it isn't inherent, it's just that.
I'm not sure what's up with that.
Oh well.
Okay.
We got one. The high temperature is the most important one.
Yeah. So let's go to 900 watts.
No stubs on it, no branches.
Oh, so it's getting up to temperature. I'm going to visit a different place.
Both ends. I want to have branches everywhere. And that cuts away from it, bounce around, so they're slower.
Because over hearing that, I can worry that maybe the relation comes to.
The cheapest dollar is 45 chips, so shoot faster.
But, I guess that makes sense considering it would be so. But in any case, that's about all I got to say about that.
Okay. I like that those parts are done.
I think I like that the
Yeah.
that's 40 US.
Yeah.
So, right on board.
Did you order more than other?
I don't know. I brought it up to Mike and Mike service group. The city was gonna order one, but I don't really. We haven't got one yet.
Yeah, more than one makes sense.
Yeah, that's a great idea.
You know,
So you didn't turn the power up then?
Yes, 900 watts.
Blows up, you might buy another one.
Might as well.
Oh, okay, yeah, the thermocouple had been 920, so now it's 982.
Yeah.
That'll make the next data point when that settles.
Really good.
Is it settled?
Still going up.
Okay.
Pretty close to settle though.
Do you want a bottle of water?
Yeah.
Yes, please.
No, I got a big glass of it.
So we've already talked.
What do you guys think?
That helps us kind of doing. Those folks that I think two or two. Yeah. Well, so this cousin, which is also my mom's cousin.
Going back down.
I wonder if we hit that point where it changes emissivity again.
This is,
Oh, the phase change in the alumina? Yeah, right at 1,000. Or it could be he opened the door, walked through.
We game on?
Yeah.
Oh, look at that. 1001. Okay. Back into the sweat zone.
At the very least, we'll totally confuse the idea of assuming an emissivity.
Mm-hmm. Well, that's what we're here for. To confuse people.
Yeah, if you assume any emissivity, you're going to be wrong. Unless you know exactly how you're using it and you've measured it in that situation.
Yeah.
In the way that you intend to.
As Piantelli says, don't try and calculate what nature's going to tell you. Don't assume what nature's going to tell you. Nature will tell you what is actually happening.
We got two of them with errors now.
Okay. Well, fine. Okay, you ready?
Yeah.
I'm in focus. Right, so I'm going to start with the alumina ceramic tube.
Okay.
On it now.
The
1250, 1264. What is the emissivity?
0.30.
0.30. Okay.
All right. The emissivity is done.
That was the tube?
That was the alumina tube. 1264. Okay, I'm now going to do the black spot. Black spot. And now on the black spot.
1030 and 0.73.
That emissivity has stayed the same.
Really?
Yeah.
I think maybe it's the thickness of that emissivity paint, and you're seeing a bit of looking through, but much less.
Yeah.
That could be.
And it's within 15 degrees of the thermocouple.
Right. Interesting.
Yeah.
So let's go and have a look at the thermocouple now. This is the tough one. I'm looking at the thermocouple now.
Yeah.
Yeah?
Call it 1130 and 0.12.
0.12 is the same. And cast the luminous spot.
Cast the luminous spot.
Just to make sure you burn all the knuckle hairs off.
Cast the luminous spot now.
1180 and 0.14.
Okay.
Can we see if we can get another data point?
Yeah, why not? Let's try.
Might cost us a coil. Actually, it'll cost Alan a coil when it gets home.
It's about 50 cents worth of Canthal wire. Not to worry. There's 1 kilowatt.
We went from 800 to 900 to 1,000. Yeah.
So, that's what it is.
I think the glove box will be about ready after we've done this.
Yeah, it will.
How exciting.
Then we can do a test, Perkamoff seal test.
Yep. Whoa. Everyone wants to see us do something Parkamoff, so we're going to do a Parkamoff seal test.
And then we'll take Perkamoff powder mix and stick it in our freshly calibrated silk carb element.
Should be interesting.
We'll see if we see anything interesting.
You've got to take it up to above the temperature of this sort of decomposition of the lithium aluminium hydride, right? And then we've got to leave it there for quite some time to soak.
Yeah. That might be the only live test we get to.
Well, maybe we could get to that point when we go to.
Okay, we just lost our last display there.
Okay, well, we still have
It was
this.
right around 1060.
1060.
I wonder what's driving them crazy.
Overheating.
Probably overheating from the back here.
Yeah.
Oh, let's put a piece of aluminum foil over it all.
Yeah. Pretty warm, are they?
Mm-hmm.
Yeah.
Yeah. Yeah, really warm.
Okay, I'm going to back this off just for a bit. Save the coil until we're ready to make it.
The problem is when you have that kind of mass, it's really hot.
There's live AC on the back terminals, so be careful with that.
You sure you want to do that?
Back terminals of these?
Yeah.
Oh, there's the thermocouple wires spanning across the top. I'll just rest it on that.
All right. Yeah, fold that in half because otherwise it's going to block your display.
Yeah. And it'll be 2 layers then, which will be even better.
Yeah. Yeah, that did it.
Hey!
Yeah, push the corner down. It's, yes, thank you. That's perfect.
Temperature's going down.
Well,
I
you turned
the
it down.
power
a bit.
down just to save
Oh,
it
okay.
till we're ready to make a measurement.
Are you taking screen grabs, right?
No.
From now on. It's a good time.
Yes.
Yeah, so here's 1 kilowatt again.
I guess this one went last because it was only getting heat from here and a bit from there, whereas the 2 in the middle.
Yeah.
I guess this one was the hottest on aggregate. That went first.
Could be. Or it had closer tolerance components or something, closer to its limit.
I got 1333 memory and 310 that's a processor. So
Wow. No, glass of water.
Yeah.
Or plastic bottle water, shall I say.
But I went with the slower memory on purpose, but I got 32 gig in here, because I just, you know, and I don't even have to put heat sink on. And I can make a lot of people overcome flat and, we all have a put heat sinks on. So.
900 watts was thermocouple 1023, so just going back over that.
The last day's point was what?
At 900 watts, I had the thermocouple logged at 1012. The display there.
I hit 1023 by the time I saw it.
Okay.
It's still rising.
Could be, and at 1,000 watts, it should reach about 1060. Maybe it'll go higher.
I'm going to grab an optical photo of that. Yeah, so on this optical camera, it just looks way brighter than it is. I zoom in a little bit, I get a moment where it's right sort of color. It's an incredible thing, the human eye. Okay, do you think that one's settled?
Pretty much, yeah.
Okay, let's do it. I'm gonna try and use this visor now because it's getting quite toasty.
Now we got to turn thermocouple at 1056.
Yeah.
Okay. Black spot.
The blacks, I'm going to start on the aluminum tube adjacent to the black spot. Right, I am on the aluminum tube.
1170, 1200, it's jumping around. But emissivity, it's jumping around too.
1250.
1250 and 0.35.
Okay, I'm going to go onto the black spot now. On the black spot.
1069, 1070, 1080, 1100, 0.64.
Ramping up. You want gloves?
What?
You want gloves?
Maybe in a minute. I've got this nice warm glow on the back of my hands.
It's like roasting a marshmallow without a stick.
Yeah.
And on the cast part,
And on the cast part. Focus on the cast part, yeah.
1290 and 0.11.
I'm sorry, I missed. What did you settle on for the black spot?
1290 and 0.11.
Sorry, no, that's the cast.
The previous one. The black
Oh,
spot.
the black spot, 1100, 0.64.
Okay.
And these are estimates within a range because of the settling time of the Williamson. It's pretty fast.
Mm-hmm.
And so it varies as the spot moves around by millimeters. It's going to see different spots on the surface. It's
Yeah.
not a perfectly flat
Or
surface.
it's, you know, it might be looking, when we're looking at the cast tube, we might be looking through to bits of the wire on gaps between the wire.
On that hottest side, there aren't any gaps.
Oh, there's no gaps.
Yeah.
Well, yeah, as you just said, talking about the hottest side, we now have it hot enough on the second one to get another data point. Do we want to do that? Because it looks a little bit thicker, that black
Yeah.
spot.
Let's do that.
So you need to kind of have a slightly different category area for that.
Yeah.
Okay, just a minute here.
All right.
Well, I can't, I got a flame blowing down, they don't want to blow down and go straight in.
Okay. And that thermocouple is reading
900, 901, 900.
Okay.
Okay, ready?
Yeah.
So I'm gonna just do the black spot. Oh no, I'm gonna do all three. So the castable, the
Yeah.
cast ceramic tube first.
Yeah.
Cast ceramic tube.
1211 and 0.28, let's call it.
12, 11, and 0.2.
Mhm.
So that's definitely just looking straight through, isn't it?
Yeah.
Yeah,
It's not a very thick tube. It's about
Thermocouple.
1 mil or something, isn't it?
Yeah, that's 200 thermocouple.
Yeah.
Okay, I'm going to go for the black spot now. Black spot.
950.84.
Okay, so that looks like it's a lot thicker than the previous spot.
Yeah.
So I think the recommendation with this kind of paint
Just pick a thick spot.
is make a couple of layers, let it dry, make a couple of layers.
Yeah, they recommend 1 to 2 mil.
Right, 1 to 2 mil.
Not
Yeah.
millimeter. If they were
No, a mil is a
thousandth of an inch.
thousandth of an inch. That's
All right.
right. They're an American company.
Yeah, not a millimeter, guys.
Yeah.
That would be thick.
Yeah.
It would be nearly as thick
Yeah.
as the tube.
All right. And I put 2 thin coats with a paintbrush on there.
Mhm.
So it should be in that range, maybe a little bit thin.
Okay, I'm going to do the castable now.
Yeah.
The castable now.
1105 and 0.19.
So the castable is, even that very thin bit of castable is stopping a very significant amount of looking through to the core wire.
Yeah, and you can see that
Yeah.
when you look at it.
Yeah.
It's darker.
But that has implications for, people that were saying that
It's
we're
harder on
looking
the
through the
screen.
alumina to the coil on the original dog bone with the coil in the center.
Yeah, definitely makes it plausible.
Yeah. No, that we're not looking through, because it's actually, there's a huge difference
yeah.
with just such a thin layer of that castable.
Do you want to put your glasses
Yep.
in front of the camera real quick?
Yeah, why not? You could do a screen grab, yeah?
Yeah.
Ready? Ready? There. And again.
Yeah, just a minute, I'm going to grab it without. Okay, we'll try another one.
And go.
Yeah, we got it right
Cool.
away.
And just out of curiosity, if you put that in front of the Williamson, what does it do?
Ooh. There's the thing.
Because the Williamson's measuring near infrared, and these are designed to filter closer to the
Go on, then.
mid-infrared.
Well, I'm going to do it on the bit where it's looking through the tube, yeah?
Yeah.
Okay, ready?
Low immediately cuts it.
Yeah.
So these are broadband filters.
Yeah.
Very effective.
Certainly makes it more comfortable to look at.
Yeah.
Right, so we haven't got the thermocouple there. That's the only thing we didn't do. So should we do that?
Yeah, we didn't get the thermocouple on the other one either. as
Did
far as
we?
I noticed.
Okay, I'll do the thermocouple on the one we're just doing.
Okay.
Yeah.
On it now.
1060 and 0.21.
0.21. That's higher.
It is higher, yeah, but it jumps around.
Yeah.
Okay, now I'm going to do the thermocouple on the other one. On the hot one. Not that any of these are particularly cold, I have to say. We are there now.
1180 and 0.04.
0.04. I think why that is because the thermocouple. I'm glancing at the thermocouple and I'm seeing some of the background.
Okay.
Yeah,
So
you have to
that's-
come down from above it and you'll be in the rising heat path. You don't want to do
Yeah.
that at 6 inches.
No, not really. So that actually supports your theory, Ryan.
The
The
convective
fact
cooling of the
that some
surface.
of what's in view
It's cooler.
is cooler, so therefore it is signal strength. It's called signal strength rather than emissivity. So maybe that is just what it is. It's just the signal strength.
Mhm.
The amount of the whole area of which is certain temperature. Maybe it's nothing to do with emissivity.
And the device does it by comparing two narrow bands of wavelength.
Mm.
And from that, it can infer how much of the IR emission is coming through the material rather than directly radiating off the
Mhm.
surface.
Interesting. Okay, we're going to crank it up and see if we can get another data point before going to fuel our reactors.
We'll do one more at 1100 watts. Keep in mind that the core at this point is up around 1400, maybe even higher.
Yeah, if the coil does what it did last time.
Yeah.
Last night. Go quite warm.
Yeah.
I have to say that it's close to the silicon carbide,
Yeah.
if not a little bit more glowy.
Well, it's transparent, so the glow is the
Yeah.
wire
You see it.
shining through.
You've seen the heating element like you did.
That's
Yeah.
true, and also this castable aluminum tube is much thinner than the one that was around silicon carbide.
Yeah.
When we're looking through this little gap here in the silicon carbide, it was a lot brighter, wasn't it?
All right, that's settled almost immediately.
Okay, let's
It's
do it.
still going up a little bit. Hang on. It's toasty warm.
So I think you can go back to the manufacturer and say, "You're right. Paint it too thin; it's no good."
Yeah.
Point one. Point two. When it is thick enough, it does really have 0.95,
Yeah.
value when you're on.
Unless you heat it over 1200 and then it turns green.
It does turn green, doesn't it? But you've got like a gradient there, haven't you?
All right.
Okay, ready?
Yeah.
So the temperature is reading. I'm going to come from the right and do each bit and I'll call it out. So
Okay.
the temperature is 1113 on the thermocouple. I'm going to first do the cast ceramic tube.
If we could make it external, if it did produce enough electricity, the whole point isn't to do anything
Okay, on cast ceramic tube.
enough for the house.
1260, 0.57.
Higher, way higher.
Okay, I am on.
Black spot next.
Now I'm on. Oh, I can't actually see because the Williamson spotter.
Yeah.
Is, okay, I'm now there.
1280 and 0.62. And where was that on?
The black spot. So it's definitely looking through still. It's not quite thick enough, that bit.
Yeah. I think the coating is degrading.
It
And
could
so-
be, yeah, it's over temperature now, isn't
Yeah.
it? Probably a bit.
Yep. And the cast next.
Okay. Cast. Uh,
1310 and 0.12.
It's interesting. I can actually see because there's enough reflectivity of that cast alumina so that I can see it,
Yeah.
this spot. So I can see the reflectivity, but the black high emissivity paint, there's no reflectivity there. So at this
Yeah.
temperatures, I can't actually see
Yeah.
the color of the spotting
All
device.
right.
So I'm going to go on to
On the thermocouple.
thermocouple. Yeah.
You might end up waking up to
Okay, I'm on thermocouple.
1280 and 0.04. And that's consistent with our previous measurement set. You want to do the second data point?
I do. Nothing would please me greater. So we are going on the castable tube first. On the castable tube.
1218, 0.35. Okay.
Okay, now on to the black spot. On the black spot.
1000 and 0.80.
Yeah, that's a much better black spot. I think probably one more layer of that paint would be perfect.
It's starting to degrade as well,
Yeah.
though, at that temperature. All right, and the cast spot.
Okay, cast spot is there.
1140, 0.18. Okay. And the thermocouple.
And the thermocouple. And the thermocouple is there.
Jumping around again. 1100 and 0.12.
Okay, gentlemen. That's probably enough for that.
I think it is. Go play
Well done.
more other games.
Yeah.
Where's the link? And where is the link? That video. We would reference that. Put it into the spreadsheet.
Yeah.
A folder for the images. And
Yeah.
I'll take a snapshot. Get to go the last. Never mind. We'll frame all later.
It's okay. Right.
Look at it glowing now. The black spot's glowing.
Wow, yeah.
Yeah, you can see it.
Unless it turned red.
I don't know. Everything looks blurry to me.
Yeah.
Yeah.
You didn't wear your glasses enough.
Not all the time, no. I couldn't see the spotting device. So thanks, guys. We're going to go off to the cupboard, and I might actually try and do a roaming camera so that we can broadcast filling the reactor tubes. Ooh, I feel like I've been standing around a campfire.
Well done.
Yeah. No, well done you. Nice tour. So thank you guys. Look out for the next broadcast where we will either be doing a Parker-Mov leak style leak test, or we will be doing something even more interesting. Putting a reactor tube into our silicon carbide element.